Hello students, in this video I would like to discuss about algorithms. So in the previous video we discussed about the purpose of algorithms, a set of sequential steps usually written in ordinary language to solve a given problem is called algorithm. So the sequential steps which is written in English language is generally considered as algorithm. It may be possible to solve in more than one ways, resulting in more than one algorithm. In the previous video we have discussed a same problem can be solved in different methods. So different algorithms will be there to solve the same problem. The choice of various algorithms depend on factors like reliability, accuracy and easy to modify. So based on these three factors, reliability, how reliable it is, what about the accuracy, how correct the output will be, and how easily we can modify the algorithm. So based on that, we will choose the algorithms. Next is characteristics of a good algorithm. Input, 0 or more input. For an algorithm, based on the solution, there may be some input or may not be some input. Suppose I want to print good morning 10 times in the computer monitor, there will be no inputs. So it is a program without any input. So it will be clear when you start studying the programming. Second one is output. We must have at least one output. So in the program to print good morning 10 times, the output will be 10 lines of good morning. Definiteness, clear and unambiguous. The algorithm must be clear and unambiguous. Unambiguous means we can't write a statements like if a number is greater than 0 and less than 0. Never a number can be greater than 0 and less than 0. That is ambiguous. There some confusion is there. In the algorithm we can't include ambiguous statements. Finiteness. Algorithm must terminate. So at some point the algorithm must end. Then only we can say it as a good algorithm. So if the algorithm didn't end, it will run indefinitely. So if I convert that algorithm to a computer programming language, and if I am executing that program in the computer, the program will run forever. So the algorithm must terminate. Effectiveness, can implement in any language. So the algorithm must be implemented in any given language. Any given language means either in C, Java, Python or similarly some other language. Correctness, for any input it must halt with correct input. So suppose if I am writing a program to add two numbers, if I am giving out inputs 3 and 5, if it gives the output as 10, it is wrong. So a good algorithm must always produce correct outputs, and also it must halt. Halt means it must terminate. So here is an example for algorithm. It's just a simple algorithm of making a pot of tea. So first step is start. If the kettle does not contain water, then fill the kettle. So for making tea, we need a kettle. So first we take the kettle. If we didn't have any water in the kettle, we have to fill the kettle. Plug the kettle into the power point and switch it on. So it is an electric kettle. So I have to push the plug into the socket and I have to switch it on. If the teapot is not empty, then empty the teapot. So anyway, after making the tea, I am going to pour it in a teapot. So I have a teapot also. If it is not empty, then we have to empty the teapot. Place tea leaves in the teapot. So after emptying the teapot, we have to put the tea leaves. If the water in the kettle is not boiling, then go to step 6. So step 6 is the step itself. So here the meaning is we have to wait until the water in the kettle boils. When I am making tea, I have to check some 2 or 3 times whether the water in the kettle is boiling. Once it starts boiling, I can take the kettle. So it is a process which has some repetition. You have to repeatedly check whether water in the kettle is boiling or not. So if the water in the kettle is not boiling, you have to go to step 6. If it is boiling, then switch off the kettle. Pour water from the kettle into the teapot. So in the kettle, we will have the hot water. In the teapot, we will have some tea leaves. We have to pour that hot water into the teapot. Then stop. So in the end, what happens? The pot will contain tea. So about this algorithm, it can be seen that the algorithm has a number of steps. Here in this algorithm, I have 9 steps. Some steps involve decision making. Steps 2, 4 and 6 have some decision making. So step 2, if the kettle does not contain water. So we have to make a decision. If the kettle does not contain water, I have to fill it. If the kettle contains water, no need to fill it. So there I have to make a decision based on the status of kettle. So again, step 4, if the teapot is not empty. So I have to check whether something is there in the teapot. There also I have to make the decision. If something is there in the teapot, I have to pour it out. Then step 6, if the water in the kettle is not boiling. There also I have to make the decision. After some few seconds, I check the kettle. I'm checking whether water in the kettle is boiling. If it is not, I have to continue the process. And after again some 5 seconds, I will check the water in the kettle again. If it is not boiling, I have to wait for some other seconds. So if the water is boiling, then I can switch off the kettle. So if we closely look at steps 2, 4 and 6, I am making some decisions. One step, step 6 in this case, involves repetition in process of waiting for the kettle to boil. So here step 6 is I have a decision making. Based on the decision, I am deciding whether to repeat the process or not. So how that repetition is implemented? By writing a go-to statement. Go-to statement means again execute the statement 6. If water in the kettle is not boiling, they again execute the step 6. From this example, it is evident that algorithms show these 3 features. So in an algorithm, we have some sequence, decision, repetition. So sequence means we have some 9 steps. We have to implement these steps one after the other. We can't implement the step 7 in place of step 2. It must be implemented in the same order or in the given order. That is the sequence. It is also known as process. So every steps can be considered as a sequence. Decision. So some steps may contain some decision statements. It is also known as selection. Some statements will contain some repetition. That means some set of statement or a single statement may implement or may execute more than one time. Here line 6 is executed more time or implemented more times. All other steps are only implemented only once. Repetition is also known as iteration or looping. Therefore, an algorithm can be stated using sequence, decision and repetition. Sequence means that each step or process in the algorithm is executed in the specified order. In the above example, each process must be in the proper place, otherwise the algorithm will fail. So if I place the statement number 7 in place of statement number 2, we can't make the tea. The decision constructs if then else. In algorithms, the outcome of a decision is either true or false. There is no state in between. In the example we already seen, if water is boiling, so it may either return true or false. If water is boiling, we can say true. If water is not boiling, the statement is false. The outcome of the decision is based on some condition that can only result in a true or false value. For example, if today is Friday, then collect pay. The decision takes the general form if followed by a proposition, then process. A proposition is in this sense is a statement which can only be true or false. If today is Friday, we will think whether today is Friday. So it may be either true or false. So in a week it will be true only once. Then I have to go and collect the pay. So in the statement it is only saying if it is Friday, collect the pay. If it is not Friday, it is not saying anything. That means if it is not Friday, no need to do anything. The decision can also be stated as if proposition, then process 1, else process 2. So here the else condition is not given. What the person has to do if it is not Friday is not given in this example. So we can write the statement like that also. If today is Friday, then collect pay. Otherwise, you can write, or else you can write something, do something, or else you can go to library. So anyway, this if then else construct will be clear when you study the examples. Anyway, this is the if then else form of the decision. This means that if proposition is true, then execute process 1, else or otherwise execute process 2. So first this proposition is checked. If it returns a true value or if it is a true value, we have to do the process 1. Otherwise, we have to do the process 2. If that means if the proposition is false, we have to do process 2. If the proposition is true, we have to do process 1. Here I have only one process. If it is true, do the process. Otherwise, do nothing. The repetition construct, repeat and while. Repetition can be implemented using constructs like the repeat loop, while loop, and if then go to loop. So already told you some steps will executed more than once. That can be considered as a repeat loop. The repeat loop is used to iterate or repeat a process or sequence of processes until some condition becomes true. It has the general form repeat, process 1, process 2, process n until proposition. From this block it is clear. I have to do process 1, process 2 and process n repeatedly. So how far I have to do? Until this proposition is true. Suppose I want to display good morning 10 times in the computer. There printing good morning is a repetitive process. How many times I have to repeat it? I have to repeat it 10 times. So there I will give some condition, whether the counter or whether the times reaches 10 until we will print good morning. So here in this example, process 1, process 2 and process n will be repeated until the proposition. Here in example, fill water in the kettle. Repeat fill water in the kettle until kettle is full. Pouring water into kettle is a continuous process. So actually this process is repeating. Pouring water, pouring some more water, that is repeating. So we can write the statement like this. Repeat fill water in the kettle until kettle is full. Here the process is fill water in kettle. Proposition or the condition is kettle is full. The repeat loop does some processing before testing the state of the proposition. So here if you look at this repeat loop, it is just saying fill water in the kettle. So you just imagine what happens though if in the above example the kettle is already full. Suppose the kettle is already full. Suppose some instruction is given to some person, fill water in the kettle. So here I already told you the algorithm will execute in sequential order. So first thing is fill water in the kettle will execute. But the kettle is already filled. So what happens? The water will overflow. If the kettle is already full at the start of the repeat loop, then filling more water will lead to an overflow. This is a drawback of the repeat construct. These things will be clear in the study example. To avoid repeat construct, while loop is more appropriate. The above example with the while loop is shown as follows. While kettle is not full, fill water in kettle. So there I first checked whether the kettle is full or not. Then only I poured the water. Earlier the instruction is given like fill the kettle. Then check whether the kettle is full or not. So there overflow will happen. Here overflow will not happen. Since the decision about the kettle being full or not is made before filling water, the possibility of an overflow is eliminated. The while loop finds out whether some condition is true before repeating a process or a sequence of processes. If the condition is false, the process or sequence of processes is not executed. General form of while loop is while proposition. Proposition means condition, which will return true or false. Begin, process 1, process 2, process n, end. So first the condition will be checked, then some processes will be done. Again condition will be checked and decide whether to execute this process again. This is how while loop execute. The if then go to is also used to repeat a process or a sequence of processes until the given proposition is false. So instead of repeat and while, we can use if then go to statement also. The kettle example, this construct would be step 1, fill some water in the kettle. If kettle is not full, then go to step 1. So after implementing step 1, step 2 is implemented. And based on the condition, we will again sequentially execute 1 and 2. So long as the proposition kettle not full is true, the process fill some water in kettle is repeated. General form of if then go to is process 1, process 2, process n. If proposition, then go to process 1. So if the condition is true, again execute process 1. After executing process 1, since it is executed in sequential order, process 2 will be executed. Then process n will be executed. Then again the condition will be checked. That's why it is very important algorithm executes in sequential order. Examples of algorithm will be discussed in the upcoming videos. Thank you.